Welcome everyone back to Through Inquisitive Kids, and I hope you're having a great day so far. In this lesson, we're going to be learning about the graphs and properties of linear functions. Chapter 4, Learn to plot linear functions and discover their unique characteristics. As you know, this is part 2 of the lesson Properties of Proportional Linear Functions. So in the last lesson, part 1, we learned about how to graph proportional functions, a type of linear function. And we just kind of analyzed and observed out their similarities and characteristics. So this lesson is going to be very familiar to you if you've watched the last video, because it's basically the same thing, but we're stretching our lenses to look at the whole of linear functions. The learning goals of today is to understand the graphs and properties of linear functions, and able to flexibly apply graphs and properties of linear functions to answer word problems. Let's do some review first. What is a function? Do you remember? And what is the relationship between a linear function and a proportional function? Pause the video and think. And 2, what are the characteristics of a proportional function, and what causes them to be? So this is from the last lesson. If you haven't watched that yet, I highly recommend you to do so. Alright, so a function is basically the relationship between two variables. And the relationship between linear functions and proportional functions is that another name for proportional functions are proportional linear functions. A proportional function is a special type of a linear function. It's just that this is when the y-intercept is equal to 0, or in y is equal to kx plus b is equal to 0. And in the last lesson, we learned about the characteristics of proportional functions. So the characteristics of proportional functions are that they all go through the origin of the coordinate plane, the graphs, and that if k is greater than 0, the graph intersects the origin, quadrants 1 and 3, and if k, which is the slope, is negative, the proportional function intersects the origin, the second quadrant, and the fourth quadrant. So let's start with relational expression y is equal to kx. We graph it, and we know it passes through the point 1k, whatever k may be, and the origin. So the graph would look something like this when k is greater than 0, and when k is less than 0, this is the graph it would approximately look like. And its properties are, when k is greater than 0, y increases as x increases, but when k is less than 0, y decreases as x increases. And now we're looking at the relational expression y is equal to kx plus b. So what I'm going to write right here, so let me write this so you'll understand this better. This is proportional functions, but today we'll be learning about linear functions. So we start with the relational expression y is equal to kx plus b, where k is not equal to 0, because right now we add a b because we know a linear function can have a y-intercept that is not equal to 0. But what about the next two steps? What would its graph look like, and what would its properties be? These two boxes are what we're going to discover in this lesson. Graphing linear functions. So in the last lesson, we learned how to graph proportional functions. The steps are as follows. First, we create a table listing all the different coordinate pairs. Then we select two coordinate pairs and we plot it on the coordinate plane. Usually the two that we select is the origin point and the y-intercept. Not the y-intercept, when x is equal to 1 and the value of k for the y value. Third, we connect these 2 points and we have the graph. Can you graph a linear function using these same steps? Well, let's try. First, we want to try graphing y is equal to negative 2x plus 1. As you can see, we have the y-axis and we have the x-axis. Here this is O, which means origin point, and this is 5. 5 and 2. So let's start. What would the graph of a linear function look like? Well, we start with the function y is equal to negative 2x plus 1. And then the first step is to create a table. And then we plot the points and connect them. So here we create a table, and the table should come up right there. All right, so basically, this is the table we have. The top is x and the bottom is its corresponding y value, which is negative 2x plus 1. And as you can see, we have negative 2, negative 1, 0, 1, and 2 for the inputs in this function. And below are all of their corresponding outputs. So what we did was plot all of these points on the graph, and then we connected them. So this is what the graph of a linear function looks like. Here's our conclusion. The graph of a linear function y is equal to kx plus b is a straight line. Therefore, 2 points need to be determined first. Remember, 2 points determine one straight line. After connecting these two dots, the graph would be complete. The 2 points are usually 0, b and 1, k plus b, or negative b over k, 0. So usually we would find the y-intercept and the x-intercept, or 1, k plus b. The graph of linear function y is equal to kx plus b is also a straight line y is equal to kx plus b. So this is what it would look like. Here, this is the y-intercept, where this graph intersects the y-axis, 0, b, and here is the x-intercept, where this graph intersects the x-axis. Use any method you prefer to graph the following two functions. Pause the video and use what we've just learned to solve this problem. Well, the first step is to always determine 2 points on these graphs. So we have negative 1 and negative 3 for the 2 points on the first function, and then we have and then we start taking these coordinate pairs and graphing them on the plane. So we have these 2 points right here. Connect, and we have y is equal to negative 2x minus 1. The next function we have is y is equal to 1/2 of x plus 1. So when x is equal to 0, y is equal to 1, and when x is equal to 1, y is equal to 1.5. Plot these 2 points, and we have y is equal to 0.5x plus 1. But you can also first graph proportional functions. Y is equal to negative 2x and y is equal to 0.5x. So what you're doing right now is turning these linear functions and getting rid of their y-intercepts to turn them into proportional functions. After you have those two plotted, just translate them up. Translate in math, we mean to move it left or right without changing the size. So you can move them around on the plane according to their y-intercept. In the end, you'll have straight lines y is equal to negative 2x minus 1 and y is equal to 0.5x plus 1. So again, what this is saying is you can first graph, say y is equal to negative 2x, it's a proportional function, and then just move that entire function down 1 unit so that it'll have a y-intercept. Please graph the function y is equal to x plus 2 and y is equal to x minus 2 on the coordinate system by plotting and connecting points. Well, this is the table we have. And then we can think, what characteristics do both graphs share? So here, this is what it would look like once all graphed down. So we have two graphs on the same plane, and think, what characteristics do they both share? Well, for one, they're both a straight line, and they're both in as x is increasing, y is increasing, and that they both have a y-intercept. Those are some things, in an x-intercept. Those are some things you can observe. Now observe the translations of the graphs of three functions. First, we translate up. Again, repeated, we translate this orange one up. This is y is equal to x plus 2. And then we translate this blue one down. Again, we translate this blue one down. And this point is its y-intercept, giving us y is equal to x minus 2. And also notice how this middle white function here is y is equal to x. They were all layered on top of y is equal to x at first. But then, as we added in, notice what changed. What changed was we added in the y-intercepts. These graphs had to translate. But what didn't change is that you'll see these are all parallel, right? So in algebra and in problems relating to linear functions, whenever you hear the word parallel, you have to start thinking slopes are the same. So slopes are the same. What do I mean by slopes? I mean the speed that they're increasing or decreasing by. So for example, even though their positions, they were translated on the graph, the speeds and the velocity that all three of these functions are increasing by are still the same. That's because kx plus b, right, that k did not change. It still remained 1. Key point summary. The graph of linear function y is equal to kx plus b passes through point 0, b, which can be obtained by translating the graph of the proportional function y is equal to kx by b units, the absolute value of b. When b is greater than 0, it is translated upwards, and when b is less than 0, the graph is translated downwards. So when you want to see whether the y-intercept of a linear function is positive or negative, all you have to do is look at the b in the relational the relational expression. So again, y is equal to kx plus b. In this formula, we know these two are the variables, and let me get another color. K right here is so this coefficient k is slope, and b represents y-intercept. Now there are different ways we can write linear functions, but this is the slope intercept form. This is the most basic one that you're going to learn, so it's always handy to just really be familiar with it. So whenever you see a relational function and it's asking for, oh, what is a y-intercept, just look at the b, look at this constant term, and then you'll know. If it's asking you for the slope, you'll know, just look in front of the independent variable, in this case x. So then think, what would the coordinates of the x-intercept be if the y-intercept is 0, b? Well, that would be negative b over k, 0. Let's do some practice. After translating y is equal to 2x up by 2 units, the function you have is, the correct answer is, okay, so here, the correct answer would not be b, it would be d. Right, D is a correct answer because when you're going up by 2 units, you have to look at this sign. It has to be positive. Second one, translate function y is equal to negative 6x upwards. Note this direction that we're translating in. Therefore, the relational expression of this new function could be blank. Well, we don't know upwards by how much, we just know upwards. So we know that this constant term has to be positive. So this is one possible answer, but as long as your constant term right here is positive, it will be fine. So plus 100, plus 2, plus 5, they're all fine. Properties of linear functions. Graph the following functions on the plane. I want you to pause the video and do some additional practice with plotting functions. All right, so this is what it would look like. Y is equal to 1/3 of x, y is equal to 1/3 of x plus 1, and y is equal to 1/3 of x minus 1. Now think, what is the relationship between the graph and the values of k and b? How does k and b affect the graph? Well, if we change it up, and if, say, we didn't have 1/3 of x, we had negative 1/3 of x, you'll see that it becomes tilted the other way. It's not increasing anymore, it's decreasing. So again, what is the relationship between KB and the graph? Well, in linear function y is equal to kx plus b, when k is greater than 0, which is, again, k is a slope, y increases as x increases. But when k is less than 0, y decreases as x increases. Very similar to the last video where we talked about proportional functions. Let's do another problem. Point 1, which its coordinates are x1, comma y1, and point 2, its coordinates are x2, comma y2, are 2 points on the graph of y is equal to negative 0.5x plus 3. Which of the following statements is correct? According to the properties of linear functions from the last slide, we know that when k is less than 0, right here the k is negative 0.5, which is less than 0, y decreases as x increases. So D would be the correct answer. If x1 is less than x2, y1 would have to be greater than y2. Notice the reverse is also valid. So if y increases, x also increases. Wait, so this is if y decreases. Decreases, okay. That's another typo right there. Judge the positive or negative of k and b according to the following graphs. Identify the quadrants that they intersect. So we have 6 right here, and I want you to find whether k and b are positive or negative, and identify the quadrants that they intersect. Well, here k is equal to 0, k is greater than 0, b is greater than 0, so they're both positive. K is greater than 0, b is equal to 0. Here, k is positive while b is negative. K is negative while b is positive. K here is negative while b is equal to 0, and k is less than 0 when b is also less than 0. And the quadrants that they intersect would be, again, the names of the quadrants are 1, 2, 3, and 4. So based off of that, you can easily identify the quadrants. In linear function y is equal to kx plus b, what influence does the positive or negative of the k and b have on the graph and properties of the function? Well, we know that when k is greater than 0, straight line y is equal to kx plus b, y increases with the increase of x. And when k is less than 0, y decreases with the increase of x. And also when b is greater, so under this circumstance, when b is greater than 0, the graph intersects quadrants 1, 2, and 3. When b is less than 0, the graph intersects quadrants 1, 3, and 4. when b is positive, under the second circumstance, the graph, and when k is less than 0, the graph intersects quadrants 1, 2, and 4, and b is negative and k is negative. The graph intersects quadrants 2, 3, and 4. Make sure as we're going and we're stopping at these knowledge key points, summaries, or conclusions, you're pausing and to take note of what I'm talking about. Practice. The graphs of two linear functions y1 is equal to ax plus b and y2 is equal to bx plus a would look like blank. The correct answer would be C. Example 3. Given the linear function y is equal to 1 minus 2mx plus m minus 1, find the value of m that satisfies the following conditions. First one, the function value y increases with the increase of x. 2. The graph of the function intersects with the negative half of the y-axis. And 3. The graph of the function passes through the second, third, and fourth quadrants. Now, if you've taken notes before, you can now refer back to them to help you easily solve this problem. Alright, so this is the solution to the first question. Since 1 minus 2m is greater than 0, solve m is less than 1/2. And since 1 minus 2m cannot be equal to 0, and m minus 1 is less than 0, m is less than 1 and m is not equal to 1/2. And for the third one, since 1 minus 2m is less than 0 and m minus 1 is less than 0, solved 1m is greater than 1/2 at the same time less than 1. Class summary. So we're almost there, just hold on a sec. Graphs and properties of linear functions. Graphs. We know the y-intercept is 0, b, and the x-intercept is negative b over k, 0. These are just really basic things that we kind of expect you to know because, when someone gives you a relational expression, they ask me, oh, what is the x-intercept? You should be able to just know. Because after training, after practice, and especially after going over this over and over again, you'll just snap your fingers and you'll know. It's just it's very basic information about linear functions, really, and it's almost like how you would recite your math facts when you were, in second, third, and fourth grade. And its properties. When k is greater than 0, which is the slope, y increases as x increases. And when k is less than 0, when the slope is negative, y decreases as x increases. Today we understood the graphs and properties of linear functions, and we were able to flexibly apply graphs and properties of linear functions to answer word problems. Thank you so much for watching through Inquisitive Kids. Please feel free to click the like button down below if you enjoyed this video or found it helpful. And yeah, just thank you for watching through Inquisitive Kids again, and we'll see you next time.